Hi, my name is William Hernandez, and this is my project on resistors. So to start, what is a resistor? A resistor is an electrical component that slows down the flow of electrons in a circuit. Resistors work by resisting the flow of electrons in a circuit. This is usually done by incorporating a material that has more resistance than the surrounding wire in the circuit, for example, nickel. An analogy that helped me understand how they work is this picture. So the pinch in the pipe is resisting the water flow, so the flow rate decreases after the pinch. Similarly, the voltage drops after a resistor in an RC circuit. Resistors are used in real life to prevent too large of a current from flowing into components that can't handle it without being damaged. In this example, I have a small circuit set up to power an LED light bulb. As you can see, without the resistor, it just blows up once the current flows through. But once we put a resistor in place, it lights up the LED just fine. Moving on to the temperature dependence of resistance. When an object is heated up, its atoms vibrate more due to the increase in thermal energy. In a resistor, this can increase the resistance as the electrons have a higher chance of bouncing off the vibrating atoms, causing a decrease in their flow. However, in some semiconductors, this can cause an increase of the flow due to the heat breaking bonds and opening up new spaces for the electrons to fill, thus increasing their flow. These two trends are known as negative thermal coefficient, where the resistance decreases with temperature increase, and positive thermal coefficient, where the resistance increases with the temperature increase. This leads into my experiment where I plan on measuring the resistance of 3 different resistors at 3 different temperatures. This will give me the relationship between temperature and resistance in the 3 resistors. First, how to read a resistor. Printed on the side of a resistor are color bands that give information on what the resistance is supposed to be. For example, on this resistor there are 5 bands, a yellow one, a purple one, 2 black ones, and then a brown one. Looking back to this chart for reference, it can be read that this resistor is supposed to be 470 ohms, give or take 1%. Now, multimeters. A multimeter is a device that can be used to measure DC voltage drop, AC voltage drop, current, and resistance. In this experiment, I will be using the resistance measurer. Here's how you use a multimeter to measure the resistance. So here we have the multimeter, the wires with the multimeter, and that 470 ohm resistor from earlier. So first you're going to take the red wire and you're going to plug it into the one that has the ohm symbol for resistance. Then you'll take the black one and put it in the ground position. Then you're going to take the 2 grippers and ever so carefully connect the resistor to the power and the ground. Then you're going to want to look for the ohm symbol on the multimeter, and you're going to start at the lowest, which is 200. This 1 up here means that the reading is too high for 200, so you go up 1 more. And as you can see, it's reading at about 432 ohms of resistance. Then to carefully remove it safely, you're going to take off the ground wire and the red wire, and then you're just going to turn it off. Now time for the experiment. First I measured all the resistance at room temperature using the multimeter. Here it is. There you go. Part 2, fridge temperature, 35 Fahrenheit. I taped the resistors to a piece of paper, put them in the fridge. Then I waited for an hour before taking them back out of the fridge. And then I measured the resistance once again. Time for part 3, the freezer, -5 degrees Fahrenheit. Once again, I taped it to a piece of paper, put it in the freezer, waited for an hour, took them back out of the freezer, and then I tested the resistances.
So here are the results from the experiment. As you can see from the graph, the 1000 ohm and 470 ohm resistors resistances increased with a temperature increase, but the 220 ohm resistors resistance didn't really change that much, showing that we didn't have big enough temperature change to make a difference with that resistor, but the first two clearly show a positive thermal coefficient.